I have a dream that one day
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X, testing concepts for the future of new rocket design.
The third type of exponential equation is what is known as the common factor type. So let's look at the first one. We have 2 to the p plus 1 plus 2 to the p minus 1 equals 20. We're going to use the exponential law that says a to the m plus n is a to the m times a to the n in order to split up the terms. So using this law over here, in the first term, we can write it as 2 to the p times 2 to the 1, or just 2. Then plus 2 to the p times 2 to the negative 1, and this is equal to 20. Now we can take out a common factor containing the variable p. In other words, we can take out 2 to the p as a common factor. So 2 to the p taken out, we are left with 2 in the first term, and we're left with 2 to the negative 1 in the second term, and this is equal to 20. We can simplify inside the brackets. We have 2 plus 2 to the negative 1. We can write as 1 over 2. And this is equal to 20. Adding the terms inside the brackets, 2 plus a half is 2.5, or 5 over 2. And now we can divide the 5 over 2 into the right-hand side. So when we divide by a fraction, we multiply by the inverse. So 20 divided by 5 over 2 is the same as 20 times 2 over 5. So 5 into 24 times 2 is 8. So we have 2 to the p equals 8. And we know that 8 is 2 cubed. So we get the base is the same on both sides again. And now that the bases are the same, we can drop them because the powers must be the same. So p equals 3. In the second equation, we have to solve for x, and we have 4 to the x plus 8 equals 2 to the 2x plus 1. Now, we're going to use prime factors of 4. 4 is 2 squared, so 4 to the x is 2 to the 2x. And then plus 2 cubed. And here we're going to split up the term using this rule again. A to the m plus n is a to the m times a to the n. So it's 2 to the 2x times 2 on the right hand side. We're going to bring all the terms in x to the left hand side. So we have 2 to the 2x minus 2 to the 2x times 2. And we're going to take the 2 cubed to the right hand side. So it's negative 2 cubed. Now we can take out a common factor of 2 to the 2x on the left hand side. So it's 2 to the 2x. Into the first term goes once. And into the second term we are left with 2. We can simplify inside the brackets. 1 minus 2 is minus 1. We can divide the negative 1 into the right-hand side. So we have 2 to the 2x equals negative 2 cubed over negative 1. The negatives cancel on the right-hand side. So we're left with 2 to the 2x equals 2 cubed. And the bases are the same now, so we can drop them. The powers must be the same. So 2x must equal 3. And in solving for x, we see that it's 3 over 2. In number 3, we have 2 times 3 to the x equals 63 minus 3 to the x over 3. There are several ways in which we can proceed here, but I'm going to rewrite the second term on the right-hand side as 3 to the x times 3 to the negative 1. Now we're going to bring all the terms containing x to the left-hand side. So it's 2 times 3 to the x plus 3 to the x times 3 to the negative 1, and this is equal to 63. We can take out a common factor on the left-hand side of 3 to the x, and we're left with 2 plus 3 to the negative 1, which we're going to write as 1 over 3. Then simplifying inside the brackets, now we have 2 plus a third is 2 and a third. And writing this as an improper fraction, 3 times 2 is 6 plus 1 is 7. So it's 7 over 3. So in the brackets we have 7 over 3. We can divide the 7 over 3 into the right-hand side, and in fact multiply by the inverse on the right-hand side. So it's going to be 63 times 3 over 7. So 7 into 63 9 times 3 is 27. So we have 3 to the x is 27. And using prime factors of 27, we can write it as 3 cubed. The bases are the same on both sides of the equation, so the powers must be the same, and x equals 3. In the last equation here, we have 4 to the x plus 3 plus 4 to the x all over 8 to the x plus 2 plus 8 to the x, and this is all equal to a half. We're going to start by simplifying the left-hand side. So 4 to the x plus 3 is 2 squared to the x plus 3. Then multiplying the powers, we get 2 to the 2x plus 6. So it's 2 to the 2x plus 6. And 4 to the x we can write as 2 to the 2x. Now, using the same principle in the denominator, we have 8 to the x plus 2, we can write as 2 to the 3x plus 6. And 8 to the x we can write as 2 to the 3x. Then on the right-hand side, a half we can write as 2 to the negative 1. Of course, here we are using the rule 1 over a to the m is a to the negative m. Now, in the numerator, we can split up 2 to the 2x plus 6 into 2 to the 2x times 2 to the 6th. And in the denominator, we can do the same. We can rewrite 2 to the 3x plus 6 as 2 to the 3x times 2 to the 6th. And we have plus 2 to the 3x left as well. We can take out a common factor in the numerator of 2 to the 2x. And in a denominator, we can take out a common factor of 2 to the 3x. So 2 to the 2x as a common factor in the numerator, we're left with 2 to the 6 plus 1. And taking out 2 to the 3x in a denominator, we're left with 2 to the 6 plus 1. And this is 2 to the negative 1. These terms cancel on the left-hand side. Now we're dividing and the bases are the same, so we can subtract the powers. So 2x minus 3x is minus x, or negative x. We now have the bases the same on both sides, so we can drop them, and the powers must be the same. So negative x must equal negative 1. And the negatives cancel on both sides. So then x equals 1. So let's check your answers to this question. In the first one, we have 3 to the x plus 1 less 10 times 3 to the x minus 1 plus 3 equals 0. We're going to split up the 3 to the x plus 1 into 3 to the x times 3 and the 3 to the x minus 1 into 3 to the x times 3 to the negative 1. Now we can take out a common factor on the left-hand side of 3 to the x. We're left with 3 here, then minus 10 times 3 to the negative 1. I'm also going to take the 3 here to the right-hand side. We simplify inside the brackets. Now 10 times 3 to the negative 1, I'm going to write as 10 over 3. In other words, we're taking the 3 to the negative 1 into the denominator and the power becomes positive. Then simplifying inside the brackets, we have 3 minus 10 over 3. So 3 minus 10 over 3. 3 can be written as 9 over 3. So we have 9 over 3 minus 10 over 3, which is negative 1 over 3. So in the brackets we have negative 1 over 3. We can divide the negative 1 over 3 into the right-hand side. So we're going to multiply by the inverse on the right-hand side, the inverse of negative 1 over 3, which of course is negative 3. So we have 3 to the x, a minus times a minus is a plus, 3 times 3 is 9. Then using prime factors on the right-hand side, we want the bases to be the same on both sides. 9 is 3 squared. So we have 3 to the x equals 3 squared. The bases are the same, so the powers must be equal. So x equals 2. In the second equation here, we have 4 to the x plus 16 equals 3 times 2 to the 2x. We're going to start by rewriting 4 to the x as 2 to the 2x. We're also going to bring all the terms in x to the left-hand side, so it's minus 3 times 2 to the 2x. And I'm going to take the 16 to the right-hand side. Now we can take out a common factor of 2 to the 2x on the left-hand side. So 2 to the 2x into 2 to the 2x once. And here we are left with 3. We can simplify inside the brackets. So 1 minus 3 is minus 2. Now we can divide the minus 2 into the right-hand side. So negative 16 divided by negative 2, of course, is 8. And using prime factors on the right-hand side, we can write it as 2 cubed. So we have 2 to the 2x equals 2 cubed. The bases are the same, so we can drop them, and 2x equals 3. In other words, the powers must be the same. And then just solving for x, we see that x is 3 over 2. Let's look at number 3. We have 27 to the x plus 2 plus 27 to the x. And this is all over 9 to the x plus 3 plus 9 to the x. And on the right-hand side, we have a third. We're going to rewrite 27 to the x plus 2 as, so 27 to the x plus 2 as 3 cubed, all to the x plus 2. And in multiplying the powers, it will be 3 to the 3x plus 6. So 3 to the 3x plus 6. And 27 to the x we can write as 3 to the 3x. Using the same principle as we did over here, we're going to rewrite 9 to the x plus 3 as 3 to the 2x plus 6. Because 9 is 3 squared. And in 9 to the x we can write as 3 to the 2x. And this is of course all equal to a third. We're going to split up the first term in the numerator as 3 to the 3x times 3 to the 6. And in the denominator, we're going to split up the first term as 3 to the 2x times 3 to the 6. The right-hand side we can also write as 3 to the negative 1. Now we can take out common factors in both the numerator and the denominator on the left-hand side. In the numerator, the common factor is 3 to the 3x, and we're left with 3 to the 6 plus 1. Then taking out 3 to the 2x in a denominator, we're left with 3 to the 6 plus 1. Then these terms or these factors cancel on the left-hand side. So we are dividing 3 to the 3x by 3 to the 2x. So we subtract the powers because the bases are the same. So we get 3 to the x. 3x minus 2x being x. Now the bases are the same on both sides. That means the powers must be the same. So x is equal to negative 1. Let's look at the last question here. So we have 16 to the x over 2 plus 1 minus 4 to the x. This is all over 8 to the x. So 8 to the x equals negative 240. We're going to start by using prime factors of 16. So just simplifying the left-hand side. So 16 to the x over 2 plus 1. Using prime factors of 16, it's 2 to the 4. And this is all to the x over 2 plus 1. We can multiply the powers. 4 times x over 2. The 2 goes into 4 twice, times the x is 2x, and 4 times 1 is 4. So we have 2 to the 2x plus 4. And then the 4 to the x we can write as 2 to the 2x. 8 we can write as 2 to the 3x. Now we can split up the first term in the numerator. We can write it as 2 to the 2x times 2 to the 4. Then taking out a common factor in the numerator of 2 to the x, or 2 to the 2x rather, we're left with 2 to the 4 minus 1 in the numerator. Now we are dividing 2 to the 2x by 2 to the 3x, and the bases are the same. So we can subtract the powers and we get 2 to the negative x. Then 2 to the 4 is 16 minus 1 is 15. Now we can divide the 15 into the right-hand side. Now we're going to get a negative answer on the right-hand side. Now no positive number raised to any power can give a negative answer. 2 of course being positive. So we can see already here that there will be no solution. And the reason, as we mentioned, no positive number raised to any power can ever give a negative answer. Example 2D deals with an important type of exponential equation called the trinomial type. And it says solve for the unknown in each of the following. So let's look at the first one. We have x to the 2/3 minus x to the 1/3 minus 2 equals 0. What's important to note about this type is that the power of the first x will always be twice the power of the second x. In other words, 2/3 is twice 1/3. In this case, we use something called k substitution. We always let the middle x, in this case x to the 1/3, equal k. Then the first x, in other words x to the 2/3, will be k squared. Because if we take x to the 1/3, which is k, and we square it, we get x to the 2/3. In other words, k squared. So we substitute the k's into the equation. X to the 2/3 is k squared. Then x to the 1/3 is k. We get a trinomial in k, or a quadratic in k, which we factorize. And now we can solve for k. So k will equal 2, or k will equal -1. We now bring the x's back in. Remember we said x to the 1/3 is k, and here we have k is equal to 2, or k is equal to -1. So this means that x to the 1/3 is 2, or x to the 1/3 is -1. So we end up with a type of exponential equation where the unknown or variable is in the base. And if you recall, we raise both sides of the equation to the power of the inverse of the left-hand side's power. So x to the 1/3, we're going to raise to the power of 3 over 1, or just 3. And we have to do it on both sides. And we do the same here. So then when we multiply the powers, they cancel, and we're left with x on the left-hand side. And 2 cubed, of course, is 8. And here the powers cancel when we multiply them. And -1 cubed is -1. Let's look at the second equation. We have 2x minus 5x to the half plus 2 equals 0. Once again, notice that the power of the first x, which is 1, is twice the power of the second x. So we know this is a trinomial type of exponential equation. So we let the middle x, in other words x to the half, equal k again. And in the first x, in other words x to the 1, will equal k squared. Then substituting the k's into the equation, we have 2x, in other words 2k squared, minus 5x to the half, so 5k, plus 2 equals 0. We factorize this trinomial, so 2k and k. 2k times k gives me 2k squared, and then 1 times 2 gives me 2, and we need minuses here, because minus k minus 4k will give me minus 5k. So solving for k here, we see that k is equal to a half, or k equals 2. We bring our x's back in. We said that here we said let x to the half equal k, and k is a half, so x to the half will equal a half, or x to the half will equal 2. We raise both sides to the power of 2 in each equation. When we multiply the powers on the left-hand side in this equation, they cancel, and we're left with x equal a half to the 2, which is a quarter, or x equals 4. In number 3, we have 2 to the x plus 1 plus 8 over 2 to the x equals 17. Now, it's not so obvious here that this is a trinomial type. We can start by getting rid of the fraction and multiply through by 2 to the x. So multiplying the first term here by 2 to the x. Then when we multiply the second term by 2 to the x, the 2 to the x's cancel, and we're left with 8. And in multiplying the right-hand side also by 2 to the x, here we are multiplying and the bases are the same. So we can add the powers. So it's 2 to the 2x plus 1. I'm going to bring this term to the left-hand side as well. Now we're going to use the exponential law that says a to the m plus n is a to the m times a to the n in order to split up the first term. So we can write the first term as 2 to the 2x times 2 to the 1, or just 2. And now we have a trinomial because the first power is twice the second power in the equation. So we let 2 to the x equal k, and hence 2 to the 2x will equal k squared. We plug the k's into the equation. So it's 2 times 2 to the 2x, which is k squared, minus 17 times 2 to the x, which is k, and plus 8 equals 0. Now we can factorize this equals 0, and then solving for k, we see that k is a half, or k equals 8. We now bring our x's back in. 2 to the x is equal to k. So that means that 2 to the x equals a half, or 2 to the x equals 8. We now have an exponential equation where the unknown or variable is in the power. So we want to make the bases the same. So this equation we can write as 2 to the x equals 2 to the negative 1, and hence x equals negative 1. Because the bases are the same, the powers must be the same. Or 2 to the x using prime factors equals 2 cubed, and hence x equals 3. Let's solve the last equation. Here we have 2 to the x plus 1 equals the square root of 3 into 1 minus 2 to the x minus 1. Now the first step here will be to get rid of the square root on the right hand side, and we can do so by squaring both sides. We know that the square root of a squared is equal to a. Then on the left hand side we have a binomial squared, and just a reminder that a plus b all squared is the first term squared, so a squared, this sign a plus, so the first term squared plus twice the first term times the second term, in other words twice ab plus the second term squared, so b squared. We can apply this to the left hand side, so it's a first term squared, so 2 to the x all squared, plus twice the first term times the second term, then plus the second term squared, 1 squared, which is 1. Then squaring the right hand side, the square root will fall away by this law, so we're left with 3 into 1 minus 2 to the x minus 1. Here we can multiply the powers. X times 2 is 2x. In the middle term on the left hand side, the 2 has a power of 1 that we don't write. So we can add the powers here because the bases are the same, and we get 2 to the x plus 1. We can also multiply out the right hand side. Now we can bring all our terms to the left hand side. So minus 3 times 2 to the x minus 1, when we bring it across, it becomes positive. Then we have 1 minus 3, which is negative 2. We're going to break up the two middle terms. So 2 to the x plus 1, we can write as 2 to the x times 2 to the 1. And 2 to the x minus 1, we can write as 2 to the x times 2 to the negative 1. Of course, here we are using the exponential law. A to the m plus n equals a to the m times a to the n. We can take out a common factor of 2 to the x from the two middle terms on the left-hand side. So taking out 2 to the x from this term, we're left with 2. And in this term, we're going to be left with 3 times 2 to the negative 1. Now, 3 times 2 to the negative 1 is the same as 3 times a half, which is 3 over 2. So 3 over 2. And here's the 2 to the x that we took out as a common factor from these two terms. Then 2 plus 1.5 is 3.5, which is 7 over 2. Now we can get rid of the fraction by multiplying through by 2. So 2 times 2 to the 2x plus, when we multiply the middle term by 2, the 2's cancel, and we're left with 7 times 2 to the x. And then also multiplying the negative 2 here by 2, we have negative 4 equals 0. So we basically end up with a trinomial, and we can use k substitution here. So we're going to let 2 to the x, so 2 to the x equal k. Then our equation becomes 2 times 2 to the 2x, which is k squared. So 2k squared plus 7k minus 4 equals 0. We can factorize this trinomial in k. Then, using the zero product rule, we can solve for k. So k will equal a half, since 2k minus 1 is 0. K will equal a half, or k will equal negative 4. Now we can bring back our x's. K was 2 to the x. So 2 to the x equals a half, or 2 to the x equals negative 4. Now, the second answer here will be invalid, since no positive number raised to any power can give us a negative answer. So our only answer will come from this equation. We can rewrite it as 2 to the x equals 2 to the negative 1. Then the bases are the same, so the powers must be the same, and x is equal to negative 1. Our final step will be to check the answer. So we're going to check x equals negative 1 by substituting it back into the original equation. Now, the reason for this is whenever we square both sides of an equation, in order to solve it, we need to check the answer. So we're going to substitute x into the left-hand side and the right-hand side. So then the left-hand side was 2 to the x plus 1. And we're going to replace the x with negative 1. So negative 1 in for x. This is a half plus 1, which is 3 over 2. Let's check the right-hand side. The right-hand side was the square root of 3 into 1 minus 2 to the x minus 1. So the square root of 3 into 1 minus 2 to the x, which is negative 1, minus 1. So we have 1 minus 2 to the negative 2, which is a quarter. So 2 to the negative 2 is 1 over 2 squared, which is a quarter. Then 1 minus a quarter is 3 quarters. So we have 3 times 3 quarters. 3 times 3 quarters, of course, is 9 over 4. The square root of which is 3 over 2. So we see that the left-hand side does equal the right-hand side, and hence our answer of -1, x was -1, is a valid answer. So let's look at the answer to this question. In the first one, we have p to the 4 over 3 equals 13p to the 2/3 minus 40. We're going to start by bringing everything to the left-hand side. So it's p to the 4 over 3 minus 13p to the 2/3 minus 40, or plus 40 rather, equals 0. This is clearly a trinomial type because the power of the first term is twice that of the second term. So we can go straight to k substitution. We let p to the 2/3 equal k, and hence p to the 4 over 3 will equal k squared. So we substitute the k's into the equation. So we have k squared minus 13k plus 40 equals 0. Now we can factorize. So k times k and 8 times 5. And we have minuses in both brackets. So in this case, k equals 8 or k equals 5. We now bring back our p's. P to the 2/3 was equal to k. So hence p to the 2/3 will equal 8. Or p to the 2/3 will equal 5. We can raise both sides to the power of 3 over 2 in each equation. Then multiplying out the powers, we get 1. So p to the 1, or just p, equals 8 to the 3 over 2. Now we can use prime factors of 8. It's 2 cubed. And multiplying the powers here, we get 2 to the 9 over 2. And here we get p equals 5 to the 3 over 2. In number 2, we have 3 minus twice root x equals x. Our first step will be to bring everything to one side. So x plus twice root x minus 3 equals 0. And we can rewrite the square root of x as x to the half. Now, notice that the first power, or the power of the first term, is twice the power of the second term, 1 being twice a half. So we know this is a trinomial type, and we can use k substitution. So we let k equal x to the half, and hence k squared will equal x. So substituting k into this equation, we have k squared plus 2k minus 3 equals 0. And we factorize. And solving for k, we see that k is equal to -3 or k equals 1. We bring our x's back in. So x to the half equals -3. Or x to the half equals 1. We can square both sides of each equation. And on the left-hand side, when we multiply the powers, they cancel. So we're left with a equals negative 3 to the 2, or squared, which is 9. And here we have x equals 1 squared, which is 1. So we have 9 to the x plus 1 plus 3 to the x equals 9 into 3 to the x plus 1 plus 3 to the negative 1. We can start by writing 9 as 3 squared. So 3 squared all to the x plus 1. And writing 9 as 3 squared on the right hand side as well, we have 3 squared into the brackets. We multiply the powers here, so we get 3 to the 2x plus 2. And we can multiply 3 squared into the brackets, and we add the powers because the bases are the same. So it's going to be 3 to the x plus 3 plus negative 1 plus 2 is 1. So 3 to the 1, or just 3. Now we can bring everything to one side. I'm also going to split up this term. So 3 to the 2x plus 2 can be written as 3 to the 2x times 3 squared. And 3 squared, of course, is 9. So we're going to rewrite this term here as 9 times 3 to the 2x. Then plus 3 to the x, and bringing everything to the left-hand side. We're going to take out a common factor here. Then also 3 to the x plus 3 we can write as 3 to the x times 3 cubed. And this, of course, is 27 times 3 to the x. So perhaps we should first rewrite 3 to the x plus 3 as 27 times 3 to the x. Now we can take out a common factor here. So 9 times 3 to the 2x. And we're going to take out 3 to the x as a common factor. So we're left with 1 minus 27. And just rewriting this, 1 minus 27 is negative 26. So it's clear at this point that we have a trinomial type, because the power of the first term is twice that of the second term. So we can say let 3 to the x equal k, and therefore 3 to the 2x will equal k squared. We can substitute the k's into the equation. So we have 9k squared minus 26k minus 3 equals 0. And now we can factorize. So we have 9k times k and 1 times 3. We need negative 26k. So the minus will go here and the plus will go here. Because you'll have negative 27k plus 1k giving us negative 26k. So then solving for k is equal to negative a ninth, or k is equal to 3. We can bring back the x's. So 3 to the x equals negative a ninth, or 3 to the x equals 3. This is invalid, this equation, because no positive number raised to any power can give us a negative answer. Of course, here we have a 1 that we don't write. So the bases are the same, and hence the powers must be the same. So x equals 1 only. Coming to the last equation here, we have 3 to the x plus 1 equals twice the square root of 3 to the x plus 1. less 2. The first step can be to get rid of the square root on the right hand side by squaring both sides. Note that everything on the right hand side, including the 2 here, must be squared. So squaring out this binomial, it's a first term squared, so 3 to the x squared is 3 to the 2x. Then plus twice the first term times the second term plus the second term squared, so 1 squared, which is 1. On the right hand side, we have 2 squared, which is 4, and squaring the square root, it drops. So we can multiply the 4 into the brackets. Then we can bring all the terms to the left-hand side. Now 2 times 1 is 2. So we have 2 times 3 to the x. We're going to bring this term to the left-hand side as well. So it's minus 4. And I'm going to split up the 3 to the x plus 1 as 3 to the x times 3. Then we can bring the negative 8 to the left-hand side. So we get 1 plus 8, which is 9. We can take out 3 to the x as a common factor in these two terms. And we're left with 2 minus 4 times 3. So 2 minus 12. Two minus 12, of course, is negative 10. And now we can see that we have a trinomial here because the first power, or the power of the first term, is twice that of the second term. So we're going to use k substitution. So then let 3 to the x equal k, and hence 3 to the 2x will equal k squared. So substituting in the k's into this equation, we have k squared minus 10k plus 9 equals 0. And factorizing, we get k minus 9 times k minus 1 equals 0. And hence k is 9, or k is 1. Now we can bring back the x's. Remember that 3 to the x equals k. So then 3 to the x equals 9, or 3 to the x equals 1. We can use prime factors of 9. So 3 to the x equals 3 squared. The bases are the same, so the powers must be the same. In other words, x must be 2. Here we're going to use 3 to the 0 on the right-hand side in order for the bases to be the same. So once the bases are the same, the powers must be the same. So x equals 0. Example 2e deals with the hidden trinomial type of exponential equation. Let's look at the first one. So we have 3 to the x plus 1 minus 4 plus 3 to the negative x equals 0. We're going to start by splitting up the first term and write it as 3 to the x times 3. Then the third term here, we're going to write as 1 over 3 to the positive x. Now we can multiply through by the LCD, in other words 3 to the x, to get rid of the fraction here. So we have 3 to the x times 3 to the x is 3 to the 2x. So from the first term, we're going to get 3, this 3 here, times 3 to the 2x, when we add the powers here. Then minus 4 times 3 to the x plus 1 equals 0. So now we have a trinomial type, and we're going to let 3 to the x equal k, and hence 3 to the 2x will equal k squared. So in the equation, replacing all the terms in x with k's, we have 3 times k squared. So 3k squared minus 4 times k, or minus 4k, plus 1 equals 0. Now we can factorize and solving for k, we get k is a third, or k is 1. And now we bring back our x's. So 3 to the x equals k. So hence 3 to the x equals a third, or 3 to the x equals 1. We can write a third as 3 to the negative 1. So we have 3 to the x equals 3 to the negative 1 here. And for the second equation here, we're going to write the right-hand side as 3 to the 0 in order to make the bases the same. So now the bases are the same and the powers must be equal as well. So x is equal to negative 1, or x equals 0. Now, just to note, in order to identify this type of equation, we can see that's always going to be a 3 to the positive x somewhere and a 3 to the negative x somewhere. And this gives away that it's an equation of the hidden trinomial type. In number 2, we have 5 times 5 to the x minus 5 to the 1 minus x plus 24 equals 0. We're going to rewrite the second term and split it up into 5 to the 1, or just 5, times 5 to the negative x. Now we can continue rewriting the second term. We're going to take the 5 to the negative x into the denominator as 5 to the positive x. Now we can get rid of the fraction by multiplying through by the LCD. Now we have in the first term 5 times 5 to the x times 5 to the x is 5 to the 2x when we add the powers. We're going to change the order of the terms slightly. Now we have a trinomial, and we're going to use k substitution. So let 5 to the x equal k, and hence 5 to the 2x equals k squared. Substituting in the k's, we have 5 times k squared plus 24 times k minus 5 equals 0. Now we can factorize and solving for k, we have k equals 1 over 5, or k equals negative 5. We can bring back our x's. K was equal to 5 to the x. So 5 to the x is a fifth, which I can write as 5 to the negative 1, or 5 to the x equals negative 5. This solution will be invalid. There's no solution here, because once again, no positive number raised to any power can give us a negative answer. And in the second, or rather the first equation here, we see that x is equal to -1. In number 3, we have 18 to the x equals 5 times 3 to the x plus 6 times 2 to the negative x. We're going to start by using prime factors of 18. So let's find the prime factors. The smallest number into 18 is 2, and it goes 9 times. Into 9, 3, and it goes thrice. Into 3, 3, and it goes once. So 18 to the x, we're going to rewrite as 2 times 3 squared all to the x. And this, of course, is 2 to the x times 3 to the 2x. So we have 2 to the x times 3 to the 2x. I'm also going to bring all the terms to the left-hand side. So minus 5 times 3 to the x, minus 16, or rather minus 6 times 2 to the negative x. And this equals 0. We're also going to write a 2 to the negative x as part of the denominator, and the power becomes positive. Now we can multiply through by 2 to the x. So 2 to the x times 2 to the x is 2 to the 2x. Here we're going to get 5 times 2 to the x times 3 to the x. We're going to apply this law of exponents. A to the m times b to the m can be written as a times b all to the m. So we can write this as 2 times 3 all to the 2x. And applying this law in the second term as well, we're going to write it as 2 times 3 all to the x. This, of course, is 6 to the 2x. And here we have 6 to the x. Once again, we have a trinomial. So using k substitution, we let 6 to the x equal k. And hence 6 to the 2x will equal k squared. So then we have k squared minus 5k minus 6 equals 0. And now we can factorize so we end up with k equal to 6 or k equal to -1. Hence 6 to the x equals 6, and 6 is 6 to the 1, or 6 to the x equals -1. This is invalid. And our final answer then is x equals 1. In number 4, we have 2 to the x into 2 to the x minus 1 equal to 15 into 1 plus 2 to the x plus 1 plus 17. We can start by multiplying out the brackets on both sides. So 2 to the x times 2 to the x is 2 to the 2x when we add the powers. On the right-hand side, multiplying out, we have 15 plus 15 times, and we're going to split up the 2 to the x plus 1 into 2 to the x times 2. We can add like terms on the right hand side. So 15 plus 17 is 32. We can also multiply the 15 by the 2 here. Now we can bring everything to the left hand side. Then adding like terms, we have 2 to the 2x minus 2 to the x minus 30 times 2 to the x is minus 31 times 2 to the x. So now we have a trinomial, and we can let k, we can use k substitution. We can let 2 to the x equal k, and hence 2 to the 2x will equal k squared. We can substitute the k's into the equation. So we get k squared minus 31k minus 32 equals 0. Now we can factorize. And solving for k, k equals 32 or k equals negative 1. Hence 2 to the x equals 32. Now 32 we can write as 2 to the 5. 2 to the x equals negative 1 will be invalid, because once again we can't take any positive number raised to any power and get a negative answer. And in the first equation here, the bases are the same, so the powers must be the same, and x equals 5. Let's look at your answers to this question. In the first one, we have 3 to the x plus 1 minus 4 plus 3 to the negative x equals 0. We can start by splitting up the first term into 3 to the x times 3. And we can write the third term here with a positive power by writing it as 1 over 3 to the positive x. Now we can multiply through by 3 to the x to get rid of the fraction here. So 3 to the x times 3 to the x is 3 to the 2x. So we have 3 times 3 to the 2x minus 4 times 3 to the x plus 1 equals 0. Now we have a trinomial, so we can use k substitution. We can let 3 to the x equal k, and hence 3 to the 2x will equal k squared. We can substitute the k's into this equation. So we have 3 times k squared minus 4 times k plus 1 equals 0. Now we can factorize. And solving for k, we see that k is a third, or k is 1. We can bring our x's back in, so 3 to the x equals a third, which we can write as 3 to the negative 1. Or 3 to the x equals 1, which we can write as 3 to the 0, in order for the bases to be the same. Now in both equations, the bases are equal, so the powers must be equal. So x is negative 1, or x is 0. In the second question, we have 3 to the x minus 3 to the 3 minus x equals 6. We can start by splitting up the second term in this equation into 3 to the 3 times 3 to the negative x, and we can also bring the 6 to the left-hand side. 3 cubed, of course, is 27, and at the same time, we're going to take 3 to the negative x into the denominator as 3 to the positive x. So we have 27 over 3 to the x. Now we can multiply through by 3 to the x. So 3 to the x times 3 to the x is 3 to the 2x when we add the powers. Then I'm going to write negative 6 times 3 to the x. And here the 3 to the x's cancel. So it's negative 27. And this is all equal to 0. Now we have a trinomial, so we can use k substitution. So let 3 to the x equal k. And hence 3 to the 2x will equal k squared. So we have k squared minus 6k minus 27 equals 0. And we can factorize this. And we see that k is equal to 9 or negative 3. We bring our x's back in. So 3 to the x equals 9, which we can write as 3 squared. Or 3 to the x is negative 3. This is going to be invalid. And here the bases are the same, so the powers must be the same. So x is equal to 2 only. In the third equation, we have 5 to the 2 minus x equals a half into 5 to the x plus 5. We can start by getting rid of the fraction here by multiplying through by 2. And I'm also going to split up the first term, or the term on the left-hand side. So it's 2 times 5 to the 2 times 5 to the negative x. On the right-hand side, the half disappears. Now 2 times 5 squared is 2 times 25, which is 50. And I'm going to write the 5 to the negative x with a positive power by taking it into the denominator. Now we can multiply through by 5 to the x. On the right hand side, 5 to the x times 5 to the x is 5 to the 2x when I add the powers. Then bringing everything to one side. We now have a trinomial or a quadratic, so we can use k substitution. So let 5 to the x equal k, and hence 5 to the 2x will equal k squared. So substituting the k's into the equation, we have k squared plus 5k minus 50 equals 0. We can now factorize and solving for k, k is negative 10 or k is 5. Now k was equal to 5 to the x, so that means that 5 to the x is negative 10 or 5 to the x is 5. This equation will be invalid because no positive number raised to any power can give us a negative answer. In the second equation, we have 5 to the 1 on the right-hand side. So the bases are the same, and hence the powers are also the same. So x equals 1 only. So example 2f deals with cross-division in exponential equations. Let's look at the first one. We have 8 times 3 to the x equals 27 times 2 to the x. Now, before we continue solving this equation, let's look at the general idea behind this method. Let's say we have a times b to the x equals c times d to the x. We can cross-divide. In other words, we can divide the d to the x into the left-hand side and the a into the right-hand side. Remember, we want to isolate the x's on the left-hand side. So we'll get b to the x over d to the x equals c over a. And b to the x over d to the x is b over d all to the x. So let's look at this equation. We're going to divide the 2 to the x into the left-hand side and the 8 into the right-hand side. So we're going to get 3 to the x divided by 2 to the x equals 27 over 8. So the left-hand side is 3 over 2 all to the x. And we can use prime factors on the right-hand side. 27 is 3 cubed and 8 is 2 cubed. So the right-hand side is 3 over 2 all cubed. Now the bases are the same in this equation. So the powers must be the same, and hence x equals 3. In the second equation, we have 12 to the 2x equals 8 times 36 to the x. We can divide the 36 to the x into the left-hand side. So it's 12 to the 2x over 36 to the x equals 8. We have a problem on the left-hand side because the powers are not the same. But we can write 36 as 6 to the 2x, or 36 to the x as 6 to the 2x. In other words, 36 to the x is 6 squared all to the x, which is 6 to the 2x. And now we have the powers the same on the left-hand side. Now we can write the left-hand side as 12 over 6 all to the 2x. On the right-hand side, I'm going to use prime factors of 8. 12 divided by 6, of course, is 2. So 2 to the 2x equals 2 cubed. The bases are the same, so the powers must be the same. And solving for x, we see that x equals 3 over 2. In the third equation here, we have 3 to the 4 times 2 to the p plus 1 equals 2 to the 6 times 3 to the p minus 1. Once again, we can use cross division. So we can divide the 3 to the p minus 1 into the left-hand side. So it's 3 to the p plus 1 over 3 to the p minus 1. And the 3 to the 4 we can divide into the right-hand side. Once again, we have the problem that the powers are not the same on the left-hand side. So I'm going to split up each term, the term in the numerator as well as the denominator. So for the numerator, we're going to write 2 to the p times 2 to the 1. And in the denominator, we're going to write 3 to the p times 3 to the negative 1. Now we can isolate the terms or the factors containing p in both the numerator and denominator. We can write it as 2 over 3 all to the p. And then times 2, I'm also going to take the 3 to the negative 1 into the numerator as 3 to the positive 1. Now we want to get rid of the 2 and the 3 here. So we can divide 2 and 3 into the right-hand side. So it's the same as multiplying by the inverse. In other words, multiplying by 1 over 2 times 3. 2 to the 6 divided by 2 is 2 to the 5 when we subtract the powers. And 3 to the 4 times 3 is 3 to the 5. So the right-hand side we can write as 2 over 3 all to the 5. So we have 2 over 3 to the p equals 2 over 3 to the 5. The bases are the same, so the powers must be equal. In other words, p must equal 5. Let's look at your answers to this question. In the first one, we have 25 times 3 to the x equals 9 times 5 to the x. We can cross divide, so we can divide the 5 to the x into the left-hand side. And the 25 into the right-hand side. Then the left-hand side we can write as 3 over 5 all to the x. And we can use prime factors on the right-hand side. It's going to be 3 over 5 all squared. The bases are the same, so the powers must be the same, and hence x equals 2. In the second equation, we have 10 to the 2x equals 16 times 25 to the x. Now we can write 25 as 5 squared. So 25 to the x will be 5 to the 2x. Now we can divide the 5 to the 2x into the left-hand side. Then for the left-hand side, we're going to have 10 over 5 all to the 2x. And 10 divided by 5, of course, is 2. So we have 2 to the 2x equals, on the right-hand side, we can use prime factors of 16. So 16 is 2 to the 4. Now the bases are the same, so the powers are equal. And solving for x, we see that x is equal to 2.